Hello everybody. Now we are going to discuss the definite integration. If you wanted to integrate a function f of x over interval a to b, therefore if the answer is f of x, then we can find f of b minus f of a. For example, if we have here a definite integral 2x minus 1 over x plus 1 dx from x equals 1 to x equals 5. So the first step, we have to integrate normally. So we have 2x, its integration is x squared. Because integration of x, you have to add 1 to the power and divide by 2. So you have x squared over 2, and you can cancel the 2. So we have x squared here. Minus 1 over x. Integration 1 over x is ln x. Integration of the constant 1 is x. Here there is no constant because we are dealing with definite integration. So there is no constant for the definite integration problems. So we have here, we can substitute x equals 5 here, 5 squared minus ln 5 plus 5 minus, substitute x equals 1 here. So we have 1 squared minus ln 1 plus 1, and the final answer is 26.39. Another example. Here we have integration 2x plus 3 to the power 6 from 0 to 1 dx. So first step, you have to integrate the function inside. So we have 2x plus 3 to the power, you have to add 1 to the power, so we have to the power 7 over 7 times derivative what inside here, so we have to divide by 2, and now use the definite integration here from 0 to 1. So we have to substitute firstly x equals 1, so you have to substitute x equals 1 here, minus substitute x equals 0 here, and find the final answer. As you can see here, this is your final answer. So we have to integrate firstly, and after that you can substitute x equals 1 in the first bracket minus x equals 0 in the second bracket, and find the final answer. We have some applications in the definite integration. If you wanted to calculate the area under the curve from a to b, this is the area or the integration of the function f of x from a to b. So the geometric meaning of the integration is the area under the curve. For example, if we have a function y equal 3x squared plus 2, find the area bounded by this curve and x-axis and the lines x equals 0 and x equals 1. First of all, you have to sketch the graph. This is the graph of the function 3x squared plus 2. And after that, you can find the area under the curve from 0 to 1. So you have to integrate. The area under the curve is the integration of 3x squared plus 2 from 0 to 1. From 0 to 1, do the integration according to the table of the integration. We can integrate here 3x squared. Its integration is x to the power 3, because x power 2, you have to add 1 to the power, so you have x power 3 over 3, cancel 3 with 3, so we have x power 3 plus 2 is a constant, its integration is 2x. Now the integration over the interval 0 1, so you have to substitute firstly x equal 1, and after that x equals 0. So the final answer is 3. You can substitute here x equals 1 minus x, substitute here x equals 0, so the final answer equals 3. So the area under the curve equals 3 units. Another example. Here we have a function y equals x squared plus x plus 4, and you have to find the area under this curve from x equals 1 to x equals 3. This is the graph of the function, and you have to calculate the area under the curve from x equals 1 to x equals 3. So the area under the curve is the integration of the given function from 1 to 3. y, which is x squared plus x plus 4. This is the given function from 1 to 3. Do the integration. Here x power 2, add 1 to the power and divide by the new power. So we have x power 3 over 3. X, add 1 to the power, x power 2 over the new power 2. 4 is a constant, so it will be 4x. From 1 to 3, substitute first the x equals 3 here. Each x substitute substitute x equals 3 and minus substitute x equals 1 here, and this is your final answer. Another example, find the area under the curve or between the curve, this curve, and the x-axis. So we have to find the points of intersection between this curve and the x-axis. Suppose that y equals 0, so solve this equation, which is the solutions or the roots of this solution is x equals 0, x equals 1, x equals 2. So area under the curve here is divided into two parts. The first area from 0 to 1 and the second one from 1 to 2. Again, we have calculated the points of intersection by equating this y 0. So if let this y equal 0, so solve the problem, solve this equation to find the roots. So the roots are x equals 0, x equal 1, x equals 3. So the first area here, this part is a from 0 to 1. Its integration, you have to integrate the given function. This given function, you can expand the brackets. So this is your function. Do the integration, x power 3, it will be x power 4 over 4. X power 2, it will be x power 3 over 3. X, it will be x squared over 2 from 0 to 1. Substitute x equals 1 minus x equals 0. So the final answer here, substitute x equals 1 here and the x equals 0 here. So the final answer is 1 over 4. This is the area here in this part from 0 to 1. Now find the area B here from 1 to 2. So we have here B equal the integration from 1 to 2, the same curve, the same function. So you can integrate as the previous step, and you can substitute x equals 2 here minus substitute x equals 1 here, and this is your final answer. The answer here is negative number. The negative here means that the area lies under the x-axis. As you can see here, the area is down the x-axis, so we have the negative number. If we wanted to find the total area, so we have to add absolute of A, absolute of the first area in the previous step, plus absolute the second area to delete this negative, which is 0.5. And now the area between two curves. To find the area between two curves, you can use this rule. If we have two curves, the function f of x and g of x, so the area lies between these two curves from a to b equals integration from a to b f of x minus g of x. And f of x is the upper one and the lower one is g of x. So the steps of such a problem, you have to sketch the graph and you have to find the points of intersection between the two curves and determine the upper and the lower, and after that use the rule of the integration to calculate the area bounded by the two curves, as you can see here, where f of x is the upper one and g of x is the lower one. Now we have an example here. Find the area bounded by the region of the curve x squared plus 1 and the line 2x plus 1. Number one, we have to sketch. This is x squared plus 1 here, and this is the line 2x plus 1. 2x plus 1, its slope 2 is positive, and it cuts 1 unit from y-axis here. So you can sketch the graph and the line, and we have to find the points of intersection. The points of intersection, you can find the points of intersection by setting f of x equal g of x. You can set f of x equal g of x, and you can solve here this second degree equation to find the roots or the points of intersection, which is x equals 0 and x equal 2. You can equate the two sides and simplify here and get x as a common factor. So we have x equals 0 or x equals 2. Now substitute to get here in our rule. Here we have area equals integration of the upper one, which is the line 2x plus 1, minus the lower one, which is the curve x squared plus 1, from 0 to 2, the points of intersection were 0 and 2, so we have to integrate from 0 to 2. Do the integration here. So we have, this is your final answer of the integration. It's very simple, you can do it by yourself, and after that use the numbers from 0 to 2, substitute x equals 2 minus substitute x again equals 0, so your final answer is 1.33. Another example, find the area bounded by the curve x squared plus 2 and the line negative x, g of x equals negative x, and x equals 0 and x equal 1. First of all, we have to sketch. Here we have x squared plus 2. This is the graph of x squared plus 2. And negative x, this is the line of negative x. X equals 0 and x equal 1. X equals 0 here and x equal 1 here. We have to calculate the area bounded by the curve and these three lines. So we have the rule. We have to write the rule f of x minus g of x, where f of x is the upper one here, minus the lower one. So x squared plus 2 is the upper one, minus the lower, which is negative x, and the integration will be from 0 to 1. From 0 to 1, here the integration, do the integration. So we can find that x squared, its integration is x power 3 over 3. 2, its integration is 2x. And here we have plus x, its integration is x squared over 2. From 0 to 1, substitute first 3x equals 1. And after that, substitute x equals 0 and subtract. So you have here, the final answer is 17 over 6. Another example, find the area of the region bounded by the graphs y, f of x equal 2 minus x squared and g of x equal x. This is 2 minus x squared. This curve is 2 minus x squared. And here we have g of x equal x. This is the line g of x equal x. So to find the points of intersection here, you have to set f of x equal g of x. So we have 2 minus x squared equals x. Collect all the terms in one side and factorize. So it is clear that the points of intersection are negative 2 and 1 here. So we have to do the integration from negative 2 to 1. From negative 2 to 1, the upper curve 2 minus x squared minus the lower line minus x. Do the integration and you will find that the final answer is 9 over 2. Thank you so much.